the effect of electron donating groups. Electron donating groups. We're going to take a break in about 5-10 minutes, so sit tight for them as much as you can. But electron donating groups. Let's actually look at 3 carboxylic acids again. I'm going to change them just a little bit. This particular compound is called formic acid. Don't need to know its name. Acetic acid, you should know its name. We've talked about it so much. And propionic acid. So this might be called ethanoic acid, methanoic acid, propionic acid. I really need a piece of whiteout right now. Well, these notes don't need to be perfect. They're a living document. You can change them and recopy them. So we have acetic acid, propionic acid. So we have these 3 acids, and our reference one is acetic acid. It's 4.75 as our pKa. Formic acid turns out to have a pKa of 3.75, and propionic acid has a pKa of 4.88. So we're going to compare these, and then it will lead us to this discussion or idea of electron donating groups. We know that electron withdrawing groups, if we could somehow put them in here or here or here, these pKa's would drop. But somehow, as we go from hydrogen to methyl to ethyl, the pK is going up. The acids are becoming weaker. Let's actually draw the 3 conjugate bases, and we'll understand what an electron donating group is. And this idea of an electron donating group, it's going to become important for us later in this particular semester when we talk about other types of stabilizing events. We're going to draw the 3 conjugate bases of formic acid, acetic acid, and propionic acid, respectively. And propionic acid. Again, all I've done is just draw the conjugate bases of these things. And we just did this with fluoroacetic acid, chloroacetic acid, trifluoroacetic acid. Now we're doing it with formic acid, acetic acid, propionic acid. We've made the corresponding carboxylates or conjugate bases. It turns out that methyl groups have the slight ability to donate electron density. There's lots of electrons in these bonds, and alkyl groups have a slight donating effect. Hydrogen doesn't have a donating effect. And so the methyl group here actually is adding electrons and destabilizing this. An ethyl group is slightly bigger. It's adding slight electron density to this reactive species and destabilizing it. This destabilization means this is less stable than this one. This one is less stable than this one. That means the pKa is getting higher, or it's becoming a weaker acid. So just as electron withdrawing groups have this inductive effect of pulling electron density away from negative species and thus stabilizing them, alkyl groups, it turns out, have a slight donating effect, and they end up destabilizing these. This is the strongest acid. One way we can rationalize it is because its corresponding conjugate base is the most stable in this pair. This is next in line. This is more destabilized. Propionic acid with more alkyl groups, more electron density sitting around, floating around here, destabilizes even further. This is where I want to stop for now. The remaining topic